Hello everyone, hope you can hear me. This is Mike, one of the co-founders of Hummingbot, and today we're going to go over something which is really near and dear to my heart, which is this gateway DEX middleware repo that I'm in the middle of refactoring right now. So we made a lot of progress since last week, so which is why I wanted to come on this live stream and do another demo of the latest changes. And this time I'm going to go over the new Jupyter as well as the new Meteora connector that we just added. It's good timing because right now Meteora is the talk of the town in Solana after it was the platform used for the Trump coin launch over the weekend. And I think now it's like the #1 revenue generating DEX in terms of fees. Also, Jupyter and Meteora are having their conference right now in Istanbul, where I know a lot of folks in the community are probably there right now. Shout out to Colin. I think we're sending a picture of the talk earlier today. But yeah, it's also a good time to be, I think, adding integrations to these DEXs. So what I wanted to do today was kind of just basically go over the new structure of the new gateway repo, especially how the new Meteora structure differs from the existing kind of like old gateway structure. And I think it's a useful kind of look at kind of like how I think how some of the modernizations in JavaScript recently have made it easier to do the same things. For instance, like error handle, clear documentation, all that kind of stuff, without all the legacy code before. So I think that what I want to do today was just kind of go over from a technical standpoint, show it off, and then hopefully but also I think talk about some of the challenges we have in kind of optimizing for Solana, because it's still, I would say, it's still, I think the way that we manage transactions can still be heavily optimized. So hopefully this is more a starting point rather than the ending point. But I do think that the Meteora and Jupyter connectors are pretty much ready to go. So I think that okay, disable the music. Right. 1 second. Let me disable the music. Okay. All right. Should be better now. So hopefully this is a starting point. Okay. All right. So all right. As I mentioned before, intro was basically I'm going to go over the new gateway refactored repo. So here it is. Basically, it's a core branch and gateway, and you can access it by basically just checking out. Basically, if you're on the main branch like this. As I mentioned before, intro is basically here. I'm going to go over the new gateway. It's basically. So here it is. Basically, it's a core. So basically, if you want to just check out you can access it. If you're on the gateway repo, you can just check out git fetch origin to fetch the latest branches from the server, and then if you're on the main branch like this, you can just go and check out the core branch, build it with yarn, so that's going to build the dependencies that you have, and then also finally run yarn build in order to compile the TypeScript into JavaScript. And then if you're running for the first time, you should run gateway setup. So gateway setup is going to copy over your certificates from your Hummingbot client. That will allow the client to talk to gateway in secured HTTPS mode. So I've already done that, so I'm not going to do that yet. But basically, to do that is very simple. Same as the old gateway. You just generate the certs in the client, and then you copy over the directory using this setup script. But I am going to copy the configs over. The configs are basically the templates. Actually, I think I've adjusted some of these, so I'm not going to copy them. But the templates are the lists and for each chain, as well as some default configs that I'll show you for Solana, Ethereum, and other DEXs that supports. Templates. Actually, I think
So still an echo. Okay, got it.
1 second. The lists and for each chain, as well as some default configs. Okay, got it. Yeah, that's right. I do have the screen playing my my other browser. Thank you, audience, for letting me know. Okay, so hopefully you can hear me now without all this random background noise that I've been introducing, because I have my headphones on and I can't hear anything but what's coming through the mic. Okay. Okay. Check. Okay, got it. Okay, so hopefully you have a good understanding of what it's doing. But basically, let me go through the beginning once again. So basically, just to use Gateway, all the refactoring is being done on this new core branch. The core branch should work the exact same way as the regular main branch. However, you basically just check out the branch, install dependencies with Yarn, then compile the TypeScript with yarn build, and then run this setup script. So I've already done this, so I'm not going to do it again. But basically what the setup script does is it copies over the certs. These certs are generated from Hummingbot, and it allows Hummingbot to talk to Gateway in secured HTTPS mode. It also copied over these templates for each template configurations for each chain and connector. So you see ones for Ethereum, you see ones for Jupiter, Meteora, Solana, and etc. And also copied over these default token lists for each chain. So here is basically the list of tokens that we have. Excuse me. So this is basically the default token list format now. Okay, so one important note is that this server.yaml, this is kind of like this is like the main configs for Gateway itself. So there's kind of two modes you can run this in. You can run this in in dev HT mode, true, which if you do that, I'll show you like this. So that will so you actually don't need the password. You can just use yarn start actually like this. Because this will basically you'll see this red button, and it'll run at this endpoint under HTTPS. So I think this is helpful if you just want to kind of inspect what the routes are and take a look, because you can just open that in your browser like this. Whoops, stocks. So this URL will basically give you the endpoints that are available in Gateway. So you can see that we have endpoints for viewing the available connectors. This is to get the configs for a specific chain or all the configs. This is to update a config. This section is to list and add wallets for different chains. And finally, we have endpoints that are specific to each chain and connector. So currently we've actually already had this, but I think before it was kind of the documentation couldn't be updated automatically. It was kind of like always had to be updated manually. One of the big changes we made recently was moving to Fastify. So Fastify is kind of like a more modern version of a node server. And so before we used Express. So Fastify has this nice auto-generated documentation where it just defines the schemas for each of the routes, and it will basically generate this Swagger UI for you. So it really helps maintain this documentation, maintain this repo a lot better. And I think some of the changes I made recently should help us maintain it, but also allow the community to add add their connectors and add the unique features and routes for the connectors more easily. All right. So the other way you can run this is in HTTPS false mode. So let me show you that. So to do that, just change. You just need to go into your conf directory. So after you ran the setup script, this was generated for you. So if you go into the conf and then server.yaml, you can change this to false or true. So now if I put this into false, it's actually false by default. And then if I stop my gateway and start it again, now it's going to tell me, oh, now I need a passphrase. And this is because I'm starting the server in HTTPS mode. So in order to connect to it, I need to start with the passphrase, and this passphrase has to be the same one that I use in Hummingbot to generate the certs in the first place. So hello? Oh, okay. All right. Bring it back. Yeah, so as I mentioned, you have to use passphrase. I always use this default A1 default. Extremely secure. Okay. So yeah, so now that it's starting in encrypted mode, you'll see this green button here. So now the endpoints are all HTTPS, and now the docs are not going to be available, because if I go to this in the docs, my browser is this will return this, and then if I go to this is HTTPS, I don't have the right certificate here. As a fallback, we do allow you to specify a different doc port. So if you specify this doc port here to some other port like A0, you will be able to see the docs on that port in HTTP. But the reason we do this is to allow Hummingbot to now access it. However, if you do want to access the routes, we highly recommend using Postman like this. So in Postman, I've done the same setup I did in basically Gateway, where I added the certs, except in Postman, there's a section in settings where you can add the certs for, and this is I just basically add the same certs I'm using in Gateway. If you want to know how to do this, there's actually a page in our docs, I think like this. So yeah, this page called Testing with Postman, I think is really helpful in showing you the steps, step-by-steps with screenshots in terms of adding your gateway certificates to Postman. And this is really helpful essentially to debug and test all the routes individually, even when they're in HTTPS. All right, so here, well, essentially we have the same kind of routes we saw in the Swagger docs. We have the config routes, the wallet routes, the chain routes, and etc. This one does not have the Meteora routes yet, because this format, as I'll show you, this is kind of like the schema of the old gateway, where in the old gateway it was really defined like a very limited set of routes, and kind of made every connector basically use the same files. And so because of that, it limited kind of like, what changes each connector could introduce. Yeah, anyway, so I think the new format, I think, should be a bit more flexible, but still allow us to define schemas for the routes that are used in Hummingbot. Okay, all right, so let's go through the route structure first and just see how we can use some of the routes and show how you can use them in both Postman as well as in Hummingbot, and also then we'll look at the new Meteor connector. So just as a preview, basically here's the overall route structure of Gateway and how it connects to the routes here. So basically there's a source directory, and there's a directory for chains, which currently defines the chains available, which currently are Ethereum and Solana, and then also one for connectors. So the three connectors we currently have are Jupiter, Meteora, and Uniswap. Note that Ethereum, these are basically chain architectures. So this Ethereum chain is designed to handle connecting to any EVM compatible network. So that's why if you look at the default ethereum.yaml file here, this ethereum.yaml file defines each network that is currently supported, where each network is defined as a chain ID, a default node URL and a default token list and default native currency symbol. So we're still, our QA team is still testing this, but I think we're pretty confident this works for each of the past chains that we supported. So we selected these chains because these are all the ones that the existing the legacy Uniswap connector supported in terms of chains and networks. So now I think we can ensure. I think we're pretty sure that the Uniswap connector has the same level of support that it did before, except we're only using one Ethereum connector instead of having separate connectors for like BSC, Avalanche, and etc. So the chain connector, and actually, so for Solana we only have mainnet, beta, and devnet, but we're trying to design this such that when there are other Solana virtual machine based chains in the future, for instance, like I think Eclipse is launching, and you have like a Fogo and Atlas, which are coming out. So hopefully those can also be supported as well, because we can add more. We can support any kind of Solana based chain here. Because what is the work? Let me kind of go through the chain connector first and describe what the work that a chain connector does. So the chain connector, the Ethereum one is a bit more complex here, but the Solana one, which I've refactored, I think is a little bit easier to understand. Essentially, there's a routes file which defines the routes that are available and make available. So there's a status route, which is this one here. So we run the status route. Let's try in Postman. So we can, like this. So as you can see, the status route returns the chain name, the current network that it's on, the RPC URL, and this is basically the stats that the chain is on. And so this current, if you look at this current block number, you can kind of verify that this node is actually updated. So next we have the tokens route. So the tokens route is just defined here like /tokens. And then the tokens route basically gives you the list of all the tokens available on that chain. So here's like this. So this tokens route comes directly from the token list that is created. And this token list, by default, it comes from the file stored here. But you can also set it up to pull from the API. Now we have the balances route. So the balances route is going to just basically give the balances for each of the asset in the chain. So I've set this up so I've kind of used more, because I use Postman quite a lot. So I have different environments for various networks that changes the native currency symbol and so forth. So that's why this is like this. But if I just run this balances command, I'll get the Sol one, USDC, and M3. So this is basically pulls the balances for the tokens you define in this currency symbols array. Finally, we have pull. So let me go back to collections. So pull basically it's just it gives you the results of a transaction. So here you'll see the transaction hash and the status, whether it's 1 or -1. And if it's 1, there should also be the raw transaction data as well. So those are basically the chain routes. And the goal of Gateway is to basically standardize the routes so that they work the exact same way. If I change to, let's say, Ethereum mainnet, or if I change to base, I should be able to run the routes in the exact same way, and with the same endpoints and the same structure, as long as I pass in the appropriate settings for that chain. So for example, if I run this for base, because this is base and this is my Ethereum address, and it should basically pull my balances for base. So these are basically my balance, my ETH, WETH, and USDC balances in base. And if I change to BSC here, I should also get my my BSC balances. And so you can see that this is pulling BNB because I'm sending BNB here as a native currency symbol. All right, so those are the chain routes, and then of course those chain routes allow you to basically interact with the chain, but in order to do so, you'll need wallets. So we have the wallet routes, which I've refactored as well. And so the wallet routes are a bit simpler, and now all the wallet routes are defined in this routes file. So the routes, basically you can list the routes, the wallets that we've added like this. So here I've added one address on Ethereum and another one on Solana. So to add a wallet, you just need to add, call this add route with the chain, which is Ethereum or Solana, the network, and your private key. So and then finally the remove wallet is simply just like this. This should be address here. Basically, and so this is on a chain level. So notice that in Gateway, this is basically adding chains on a this adds walls on a chain by chain basis, not necessarily chain and network. And that's by design, because if you look at the wallets today, a lot of them, they're designed to kind of handle multiple networks in the same chain. And so, whereas right now, I think in Hummingbot, the wallet interface kind of assumes that you're assigning a certain wallet to a chain and a network. So there's a strong possibility in the next 1 or 2 releases that we're going to change how that interface in Hummingbot works to Gateway, so that when you add a wallet, you can just use that wallet across any of the networks on that chain, and you can use different wallets for the same DEX. All right. Okay. So let's finally now we've covered basically the main kind of general endpoints. We've covered the chain endpoints. So let's get to the meat of Gateway, which are the connector endpoints. So the original Gateway design, the way it worked was that it really wanted to kind of define precisely certain routes, like getting a price, doing a trade, and estimating gas, and but it was kind of limiting because it was hard to add more and more routes. It's because each route you had to do this where, for example, for Uniswap, there's a routes, you add a route, then you added a controller, and then you also added actually usually another kind of logic handling file somewhere in this Uniswap client, and there's actually another validators file that I think I've already removed. So there's just a lot of steps in adding specific routes, and it was hard to kind of track how they worked. So that's kind of why for the current implementation, for AMMs, we really only have three routes, which is getting a price, doing a trade, and estimating gas. But this is actually more at a chain level, so there's really only 2 main routes that are kind of supported. So as a preview, this is actually one of the things that I changed around when rebuilding the Meteora connector. So the Meteora connector, unlike these other ones, there's a routes folder, and this routes folder, each one of these routes files, each of these files contains all the logic in addition to the route itself. So I think it results in a more flexible structure. But anyway, but at least for Jupiter, because I wanted to make sure that Jupiter, because it's used for arbitrage, this is probably the main functionality that exists today. I want to make sure it works with the current Hummingbot client. So that's why I built the Jupiter connector in the same style as the existing Uniswap connector. However, with the new Meteora connector, I changed things around. So it's gonna have like the new route structure, and I think I'll probably rebuild I'll probably build the new connectors using this new route structure as well. But first, before we get into Meteora, let's run the Jupyter connector first. Let's make sure we can do kind of like use the routes and see how it works. So first, this connectors route, basically this one just shows you all the routes available. So we can see we have Uniswap, the trading type AMM, and what chain and networks it's available on, and then Jupyter trading type, and also the chains and networks that's available on, and finally for Meteora. So next, let's actually get a price. So let's use Jupyter and get a price to buy a token. So basically we're going to pass in the we actually don't need this chain anymore. I'm going to remove this because we don't need that anymore. Basically, we need to pass in the network, the connector. Actually, should this work? Yes, that's right. So yeah, so the network, which is going to be mainnet beta, the connector itself. Actually, sorry, we do need the chain here. No, we don't. No chain. Yeah, so we don't need a chain here. I don't think we need the connector anymore. Let me try this without the connector. Let's try this. Okay. Okay. Sorry, we do actually need these properties. I feel like we don't need them many, but let's use them anyway. Sorry, chain ID. What is going on here? Oh yes, it's because we're not using Solana. Okay, so let's use Solana. Okay. All right. So what we just did was we just did a query to we called the Jupyter / price endpoint on gateway, and so we asked it for the price of buying one M3 for this quote asset, which I always define as USDC. So what is M3? M3 is basically this token of this new platform called M3 that the Meteora I think just launched today. So this is M3 where you can basically it's a new mechanism where you can take meme coins and basically stake them in order to earn the liquidity rewards paid to LPs. So it's kind of I think it's a pretty novel mechanism. I'm a holder, I guess, as well as a staker. But anyway, so the reason I'm using M3 is because it's gone up a lot today. It's very volatile, so it's a good way to test how well we were able to land transactions on like a more competitive token like this, and how much fees we're paying in order to land that transaction. Okay. Can you make Postman a bit bigger? Oh, wait, got it. Yeah. So yeah, let me make Postman a bit bigger. I think yeah. Okay. I think I can increase the width here. I always need to. Okay, yeah. Okay. This should be good. Okay. Yeah. Hopefully that's a little better. Yeah. Thanks. Yeah. Just please give me feedback. I think sometimes it's hard for me to do the technical part of these live streams well. But okay, all right. So now let's go over. Let's actually try to actually execute some swaps, and I'll kind of go over like what gateway is going to show you in terms of executing these swaps and how it does that. All right. So first, let's just try one first. So let's get that buy quote again. Update it. So now we can see that we basically fetch a quote to buy 10 units of M3 in USDC. And what we got back was we said, okay, the price is going to be 0.095 USDC. So that means that if you want to buy 10 M3, then you'll need 0.95 USDC. So we can verify that basically by kind of going to the, by doing this, by going to Gecko Terminal. We can also check out what the swap looks like in Jupyter. But this current price looks like it's pretty close to the actual price in Gecko Terminal, and it's probably the actual Jupyter price. The other reason it's probably a bit higher is because of our slippage settings. So because what's on Gecko Terminal is the market true price. However, when we do a swap, we need to pass in a allowed slippage. So this expected amount incorporates the slippage. In actuality, you might get a price that's better than that, but that's kind of like your floor of what you're going to get. So to change slippage settings, we can go to Jupyter and we can change it. We're already using 1%. This is actually already pretty low, so I'm going to just go with this. But yeah, that's an important parameter to set. Okay, so now that we understand that kind of thing, so note that this is the gas price. So we're going to estimate the gas price, and gas is different for every exchange. So right now we're saying the average gas price is this, but the way this is actually calculated is this is the gas price in Solana terms, and it's a combination of what this current gas price, which is in the priority fee that you want to pay, multiplied by the compute units limit. By default, it's 200,000 is the default kind of average, I guess, the per transaction. But what we're actually going to do is we're going to use the actual transaction usage on a transaction by transaction basis. All right, so basically the way that it fetches this gas price is it's going to fetch from the node recent transactions and look at how much fees those transactions paid. So it said that the recent transactions had a range of 1 to about 2 million micro LAN ports per unit, an average of about 180K. This is actually pretty expensive. And the priority fee is using is this. And this is because we set a minimum fee over here in Solana. So in Solana, this Solana YAML file defines the assumptions you're going to use when trying to send transactions on Solana. And so these are actually pretty important because I think the most important times to get transactions landed are in times like today, when it's really congested and you're trying to buy or sell something like M3, which is moving in price quite a lot, and where there's a lot of competition for block space. So let me just walk you through the key assumptions here. Let me make this a bit bigger. So the first one is how many units do we assume when we estimate gas for a transaction? So this is basically what's passed into estimate gas here. So this, I believe, is the default transaction compute units in Solana. So we use this, but it could be a much higher if your transaction is gonna do a lot or add touch tokens and of different kinds. So this number is the percentile rank, I guess, of the recent fees you're sampling. And so if you pick 0.5 here, it'll take the median transaction fee. If you do 0.9, it'll basically pick the 90th percentile. So it'll make sure this fee is greater than 90% of the fees in the sample. So it kind of just gives you the starting point in terms of what is your base priority fee. And then because so the way it works in Solana is you send transactions, and the only way you know if it's confirmed is if you basically see it in a block. So basically the strategy is to send transactions at a certain fee level. If it doesn't work after a certain number of tries, you step up the fee, and then you try again. And then if that doesn't work, you step it up again and try again. So that's why the other variables here are the multiplier. So how much you increase every time you step up. The retry interval. So the interval between retries and the retry attempts at a certain level. So by default, the default assumptions are you're going to retry for 5 seconds at a certain level, and then afterwards you'll step up. You'll basically double the priority fee afterwards. And finally, the last two assumptions are the minimum and maximum priority fee you want to pay when you're sending transactions. So the minimum fee is, currently, as I said, is 100,000 This is in land ports, so it's like 0.001 Sol. And this one, the maximum I said this is 0.01 Sol, which is like $3. So I'm doing this for testing, but actually I think it's also quite expensive right now. Typically, I may actually set this lower to 10,000 or 500,000. But I think right now, because it's a congested time, I'll set it a bit higher. Okay, so those are the main assumptions in Solana. So let's go ahead and actually do a swap and try to actually see how that works. This is probably too big. Yeah, probably size. Okay, all right. So let's get a price again over here. So note that basically the logs here are going to kind of tell you what's happening. Overall, we're trying to improve the logging as well. Currently, the gateway logging, there's actually pretty good logging on the gateway side, but not a lot of it is being transmitted over to Hummingbot if you use it in Hummingbot. And I think that we probably have an opportunity to simplify how that works during this refactor. Okay, so let's get a price again. So here the price is still about 0.095 to buy, and so now we can do a trade. So yeah, so first it's going to send the priority fee with 0.01 Sol, and so it's confirmed already. And so great. So this is the hash, and then if we actually look at the hash on SolScan, we should be able to see what it looks like. So here's the transaction itself. We swapped 0.95 USDC for 10 M3, and we paid a fee of 0.02 cents for that. So actually, we probably could have paid a lower fee for this. So let's go ahead and actually change that. Let's stop gateway, and I'm going to go into Solana, and I'm going to drop this to 10,000. Okay, so that just lowered the minimum fee by a factor of 10. So now I'm going to send with a starting fee of like 0.01 cents. Okay. All right. So let's try that again, and then we'll see how that works. So now I think I bought some M3. So let's take a look. Yep. Now I have 265. So now let's go ahead and sell some of the one we bought. So now I'll sell. No, this will send a sell transaction. Ooh, okay. So this error, okay, yeah, this error is because the Jupyter API was not available. So I'm not sure actually. Yeah, let's try that again. So that could be just a temporary thing. Sometimes the Jupyter API isn't available, so maybe we should do more retries there. So yeah, so this will take longer because remember that we made our starting fee a lot lower. The minimum fee is now 10,000 land ports, and so it took a bit longer, but actually it did get confirmed again. So now here's the transaction that we confirmed. So let's pull this up in a different window like this, so we can see the difference between the second transaction, which is the one on the right, and this one. Actually, this is probably the better order. So the one on the left was the first transaction we just did, and this one was the second one. So this one was just swapping 0.095 USDC for 10 M3. This one swap 10 M3 for USDC. So note the price difference. There is that's why there's not always going to be arbitrage opportunities, but because there is going to be slippage between even on Jupyter for tokens like this. In terms of fee, it looks like the fees actually were pretty similar here, because I guess the first time around it doubled quite a bit. But overall, let's see here. Yeah, this one actually this one actually ended up being a higher fee because it was 0.28. So overall, the math here, we're still trying to make sure actually this is correct, but overall the idea here behind the way we I set this up here is that this should give you a lot of control over how to kind of basically how to send land transactions on Solana, because you can start with basically you sample the blockchain for the transactions. Then you can basically estimate with a base fee. Then you can basically determine the retry intervals to send one and to cover one up. I do see a question in the chat about kind of like, oh, okay, got it. So yeah, Constant says, I'm pretty new. Can you summarize where Gateway is coming into play or sentence to? Oh, is it for Hummingbot to place trades on various networks, DEXs? Yeah, got it. So yeah, so apologies for not the context. We try to do these live streams every week. So in some ways, you can always refer to the previous ones. But overall, Gateway Hummingbot is Gateway is basically DEX middleware for Hummingbot. So the problem that Gateway addresses is the fact that most blockchains and DEXs have some type of a JavaScript SDK. And then so you probably need to interact with that SDK if you want to find the optimal route, let's say, across all the pools. So it turns out that every SDK is different. And so ideally you want to use SDK themselves instead of rebuilding from scratch. However, because Hummingbot is in Python, we use Gateway to essentially standardize the libraries of the SDKs into standardized REST endpoints. And then now Hummingbot and frankly any other client can talk to it talk to it. So the Gateway project actually has been around for a long time, and actually there's been a lot of interest in the community to add connectors to it. So the main branch of Gateway, if we look at how many connectors it supports, there's probably about let's see, there's probably about there's quite a few exchanges, the DEXs that it supports, and there's quite a few kind of chains as well. But to be honest, like the actual level of support here is, in my opinion, not that high, because a lot of these chains are just kind of really just EVM chains, which could be defined as networks. And a lot of the code in these connector folders was really kind of duplicative. So that's why during the refactor, what we're doing is we kind of removed these other connectors for now in order to have a more streamlined version of Gateway, rebuild the Meteora connector using a different route structure, and hopefully offer like a better template that the community can then use to add the other connectors back, and then add other connectors using a better style. But I think that the key thing that I think Gateway does is it also handles the complexity of kind of landing a transaction on the chain. And then that's actually a lot of the code. If you look at the code in the Ethereum folder, a lot of that, and that's where I didn't really touch a lot of that. A lot of that is just designed to actually ensure that your wallet isn't stuck, that you're using the correct nonce, and that you're also sending, using a gas level which is high enough to actually ensure that it lands. Because in Ethereum, if your transaction is stuck, then it basically blocks your wallet from doing anything else afterwards, and you have to essentially send another transaction to cancel that first one before you can do anything else. Unfortunately, this live stream this one is not going to be designed for beginners. That's why we do offer this bot camp program, which has courses for beginners. There's also, I think, a lot of intro videos on our YouTube as well. But we kind of we try to aim these live streams toward basically showcasing the latest and greatest Hummingbot, which unfortunately it tends to be fairly technical. So basically Andrew asking, could one program an algo to trade the auction slot mechanism in XRPL? Yes. I would say if you're going to do that, you're probably not going to be using Hummingbot, because Hummingbot is kind of like a framework that is like helps you do one thing. So Hummingbot does have an XRPL connector, but that connector is really designed to allow someone to interact with the trading endpoints currently. Now, could we add integration to the auction slot mechanism in XRP? Absolutely. So, but a developer will have to add that functionality in because the current integration with XRPL is designed to handle the trading functionality only, if that makes sense. Okay, so let's get back to the actual gateway. Let's actually see so now we see a trade happening. Now let's go ahead. Before we do that, let's take a look at the how it works in Uniswap as well. So in Uniswap, basically we just need to change our environment to base. And let's go to the so now what I do here is so now this connector is going to be Uniswap. So now let's fetch a price for Uniswap. So note that the Uniswap, the configuration file has all of these kind of contract addresses for the different chains and networks. So our QA team is actually still testing all this to make sure that all the addresses work correctly. But the idea behind the new design is that this Ethereum chain folder should be able to handle any EVM compatible network. So that's why these networks can just be defined as EVM networks. And if we just define these Uniswap chain addresses, you should be able to trade on Uniswap across the board. So for instance, on base, let's see, on base we have this. So let's fetch a price for doing WETH and USDC. I think I have like 0.001, something like that. So we can get a price for that. I think I do have enough. Let's see, WETH. So this should tell me my WETH. Yep. So I have 0.005 WETH right now. So let's sell. Sell some WETH. Do a selly. Oh yeah. One question: can we be using future to monitor CLM pools and rebalance them? Absolutely. So yeah, that's actually what I'm going to show off in the second half of this demo. But I want to show off the current state first before this is kind of like a more extension of what I showcased last week. So bear with me. I'm going to show off the CLMM functionality pretty soon. So all right. So now that we can do a trade on base. So this is the price to sell on base. And so let's actually do a trade on base as well. So this is the base token, and we want to sell 0.001, right? Yes. So we should get 3 USDC after we do this trade. Let's pull up this. So okay. So now, yep, the transaction is executed. We have the hash here. So we can actually also use it to pull for the hash, and notice that I'm calling the same endpoints, and all I'm changing is basically the chain in the route name, and I'm defining an Ethereum hash instead of a Solana signature. So this gives you the data for the transaction, and so we actually did do a trade on base. All right. So now before we look at the Meteora integration, let me just show you again how to run an Arbitrage bot in Hummingbot that uses Uniswap or Jupiter in order to trade on Ethereum versus Solana. So that's probably the core, I would say, the use case available right now with Gateway. We are going to add the CLMM functionality. But with that part, we're probably going to just add the endpoints first, do some test strategies, but we won't have a kind of a fixed Hummingbot strategy that people can run for a while. However, for Arbitrage, we already do, because for Arbitrage, you just need the endpoints to fetch a price for a swap, and then once you want to do a swap, you just need to actually be able to execute that swap. So so to do that, so first make sure that your gateway is not running in dev mode, because if it is, it won't be able to connect Hummingbot. But if it is, so mine I believe is. And so now in Hummingbot here, we can basically, oops, sorry. Okay, so and so now, because I've already done the certification stuff, I see this gateway online here, and so this Hummingbot is now talking to this gateway I'm running over here, and I can run commands like gateway balance to see what I have here. Unfortunately, this command takes a bit long because I'm fetching for across a bunch of networks, and for each of the tokens, I'm also getting the allowances as well for the balances. So we're probably going to make this a bit more functional in the future. So there's like a separate command for balances and for allowances, and you can also basically I think, and also we'll probably also, as I mentioned before, allow you to use just add a wallet on a chain basis, and then also so then you can use that wallet across any of the DEXs by just passing in the wallet address. That's actually how Gateway works already, but in Hummingbot the initial design of this interface probably needs to be improved. Okay, so but now that we have balances, as you can see, I have 245 M3 here on Solana with $138 US, and I believe actually okay, I can run it. Actually, let me just do one thing over here. This should work. Okay, let me exit. I think unfortunately I'm arbitraging between Jupiter and KuCoin, and I believe that KuCoin recently started geo-restricting their API. So I just turned my VPN on, and so now let's try balance again. Okay, yep. As I mentioned, so now it is fetching my KuCoin balance because I turned my VPN on, and so I have some M3 there as well, and some USDT. And as a reminder, I also have M3 on Jupiter. Oh yes, this is because I changed my VPN. Okay, got it. Okay, the Brazilian VPN still worked. So I have M3 and USDC on Jupiter versus M3 and USDT on KuCoin. So that means I can run the script to basically arbitrage it. So let's open that up. So I'm going to open my Hummingbot folder. I think I showed this last week. So I just want to basically just verify for you guys and for myself that all the changes I made during the refactor didn't impact the ability for this thing to run. So here's the arbitrage controller config file I defined. So this is saying the first leg of the arbitrage is KuCoin, M3 to USDT, and the second leg is Jupiter, Solana mainnet beta. This is the name of the connector here in Hummingbot, and the trading pair is M3 to USDC. So now we're going to use one USDC as the quote, which is around 10 M3 for the amount. And to force it to do a trade, I'm going to trade even if the profitability is as low as negative 0.5%. In addition, excuse me, my daughter's. Sorry, I shouldn't blame my daughter. My daughter's in 5th grade, so it's probably some classmate of hers that's sick, and gotten me under the weather as well. By the way, before I proceed, there's a question from Alex. If I want to create a grid strategy with multiple levels for Solana, is there a course for that? Is Mac more friendly for Hummingbot? I would say, yeah, there isn't a course yet, but I think after the DEX integrations we're adding right now, and also the sample strategies that Fade's adding, yes, you will be able to. In fact, this is actually one reason why we paused our Botcamp cohorts for a little bit, because we just want to focus on engineering, really build out these DEX integrations, especially Solana, and also run strategies for ourselves using it, so that when we teach them in Botcamp, we actually know what we're talking about. And we have a tool set like Gateway, which is designed to allow you to do anything you want on any DEX, hopefully. The rate connector. Well, yeah. So the I'm not going to go into a lot of detail into the rest of Hummingbot outside the DEXs, but basically, if you just run the connect command, you can see the list of the spot and the perpetual order book exchanges that Hummingbot integrates into. So by design, Hummingbot it integrates with order book markets. So whether it's a DEX like Hyperliquid or a SEX like Binance, if it's an order book, the Hummingbot connector is going to handle that in the same way. And then we have a separate kind of order book, market connector design for perpetual markets, because perpetual markets, the logic is different, and so that's why all like basically there's a separation in that way. So the other market type that's common in the blockchain space are AMMs, but because AMMs really basically only exist on DEXs, that's kind of why we run all the AMM integrations through Gateway. So we kind of discovered over the years that this kind of matches how the current landscape looks like in crypto, and we're open to kind of adding, as we basically want to shift as the market evolves. But I think right now it seems like those are the three core market designs which are getting traction across many exchanges, and then we can also standardize interaction with those three market types. Okay, so that was a bit of a distraction, but let me just go ahead and start running a bot just to show you how it actually works. So we have this configuration file here. This is going to arbitrage between KuCoin and Jupyter on M3 M3. So to start it, I just need to run my quick start command that I've saved. Okay, so yeah, this is a bit of a hack, but this is basically going to run this quick start file, pass in my password, pass in the loader script, and pass in this loader script config, which has this in it. So you can see that over here. Yeah, this one refers to this arbitrage controller Sol. All right, so let's go ahead and run it. So this is probably not going to make money, but I just want to see, hopefully, transaction is landing, and getting filled, and actually, so this looks like it worked. Let's see. Okay, interesting. It looks like actually my okay. Is it so one order has failed? Let's see. Okay. All right. Good. Yes. It looks like this is the Jupyter swap API error. So yeah, we don't handle that well right now. But let me try to restart. It looks like it did handle that. Looks like it recovered, but no. It looks like the API is still not available. All right. Let me stop that again and try that again. But overall, yeah, I think especially on days like today when Jupyter is having their conference, there's a likelihood that their API is going to have more issues. However, we should try to handle that better. So unfortunately, we need to interact with API because that's basically fetching the route for the trade. So the way it works in Jupyter is you pass in, the input token, output token, the amount, and also your desired slippage terms, and it basically gives you back the swap object. Actually, you also add in the priority fees, and then it gives you swap object. But let's try that again and see if we can get that running, avoiding the Jupyter swap API errors. Okay, so this is filling on KuCoin. It sent the order on Solana, so now it's polling for it. So now I found the order. So this is one filled trade successfully on Solana. Here, let's see, here, and then and so this second one, here, I bet is hitting the. Oh no! So this was actually this is probably the simulation error. So yes, some of the stuff, as you can see, multiple things can go wrong once you are trading the blockchain. This simulation error is probably because of slippage, actually. So basically, the way that this will work, you'll see errors. We'll probably we can definitely improve the error handling here quite a lot. But I think the core logic of the connector is working now in terms of it's sending orders. It allows you to increase the fees and handles polling for the transaction afterwards. So let's see. So let's look at the status and see how many successful trades versus failures we have. So currently we've done 3 trades on Jupyter versus 3 on KuCoin. So it looks like we're actually matched right now in terms of buys and sells. And then on the status command, this shows you how many failures we have. So yeah, we did have a couple of failures, but the arbitrage executor, should be designed to kind of handle these kind of failures. So I think we should probably we should look at the logic, but I think that it's designed so that if one leg fails, it'll keep on trying that leg until it succeeds, and then so that's why even if there is a failure, if it recovers, and there's this, it's a good chance that you actually will have a matching here. But yeah, we have probably some work to do to improve like the resiliency of the arbitrage strategy versus failures like this. But we should note that you should probably expect some level of failure when you're running arbitrage, because a lot of things can happen, once you decide to do a trade and getting it actually confirmed. So maybe the price might move. Maybe you have issues sending the transaction on the blockchain side. Maybe gas fees spike. Those kind of things. So I think that the approach that we're going to take for the arbitrage strategies here are probably going to be more toward tracking how many failures you have, trying to recover, and then if you can, just logging it and tracking the imbalance you have, versus trying to reverse every trade that you've executed. All right, so yeah, we've done a few more trades. So far we haven't done that badly. We've lost a grand total of 7 cents so far. This table is designed to track basically each leg that was executed, and then so some of these are actually open and some of these are closed. We can also improve this. We're going to improve the status of this quite a bit in the future as well. So you can see that it looks like there was some imbalance that we have. So that could be temporary. It's possible that Jupyter is still in the process of trying to get confirmed for something. Let's see. So it looks like there is some imbalance right now, because it's traded 55 M3 in KuCoin, -5 here, and then it's done fewer trades on Jupyter, and this delta is likely due to failures. Okay, so let's stop this trade. And then we can do the same thing on base if we want. But I think what I wanted to really feature today was looking at the new endpoints that I added in the last week for Meteora. So first, before we do that, I'm going to change the where's gateway? Yeah, so we go gateway here. So I'm going to change this to true, and the reason is because I could interact with it in Postman, but what I did was I focused the Meteora endpoints on adding them in regular mode as well. So what that means is I can build. Oops, there's something about here. So yarn build. Just make sure I can build that again. I don't think I made any changes, but I might have. So yeah, so I can run start. I actually don't need the password A, but so now it's running in development mode. And so now it means I can just access the documentation at this URL and then interact with the endpoints directly. Okay, all right, so here's all the endpoints in Gateway. And so this is basically the same ones we saw in Postman, but we can access them just like this. So we can see, like, for instance, the list of wallets, this, or the list of, let's say, connectors. You see, it's really the same data that was in Postman, but I think this will be easier to interact with if you're just testing it out for the first time. So to do that, all you have to do is change this dev HTTP mode to true, and then run it that way instead of which is false by default. Okay, so let's take a look at some of the Meteora endpoints we added. But before we do that, let's look at the structure of the connector versus what the endpoint structures are here. So remember that when I showed you the previous Jupyter connector, there was essentially one routes file that had all the routes defined in it. And so what I found was that actually makes it hard to make a community, get a community contributors, because everyone's editing one file, and it's hard to kind of have a single, like everyone can add routes and do different things. So for Meteora, I used the new kind of the LARP style route structure. So we had this experimental repo called LARP we were testing out. So this one, I used that structure. So now there's basically one kind of Meteora routes file like this, and in all the routes files there's basically individual routes for each of these routes. So for example, this position own route, it basically, this one file, this is basically the route handler over here. And there's a helper function that I uses to kind of to create the response. But most heavy lifting is done by this get DLM pool function, which is in the core like Meteora client. So this structure, so essentially each of these files does the error validation, has any custom logic, and uses kind of shared utilities that are in this Meteora.ts file for interacting with the Meteora SDK. So contrast this to how it looks like for Jupyter, where in Jupyter, there's every possible route is defined in the routes file, is pulling individual schemas for each route from another file. There's for each route has a separate controller function, and each of these functions refers to individual kind of like another kind of like function here in Jupyter. So, and this is actually after I've removed a lot of cruft that existed for previous gateway connectors as well. So that's why I didn't want to build on top of the design. I think that this new Meteora structure, where every route is its own file, makes more sense, because then every file you can just define the schemas for the route like this, add liquidity request, add liquidity response, and we can like define the route as well in the same file. So currently for Meteora, I'm just using, I'm just trying to map what we previously had for LARP. So that's why these the requests and the response schemas and even the route names might be different. But yeah, it should basically, this was designed to essentially mimic the same endpoints that we have in this more like a research LARP repo that had endpoints for Orca and Meteora. So actually, if you actually want to use Meteora endpoints, you can already do so right now by just going to LARP. But now I think this now you can also use it with Gateway, because I have the Gateway version of these endpoints. So let's take a look at these endpoints and how they work. So let me make this a bit smaller over here. Okay, so let's look at the position owned first. This is just positions that you own. Let me pull up Meteora first as well, and my test wallet. Oh yeah, one note on roadmap. So yeah, this document here covers the roadmap doc. I think we shared this in Discord. So basically the plan is currently to essentially for this V2 release, which is coming out in next week. This is going to have the cleaner stripped down version of Gateway in it. So it'll have support for Arbitrage on Jupiter and Solana. I'm sorry, Jupiter and Uniswap. So those two connectors should basically work the same way that they did before. The other connectors we're going to reserve until we kind of finish refactor and then add them back in. But at least for Jupiter and Uniswap, they should work. And Uniswap should work across all the networks, including BSC and Avalanche and Polygon and Celo that it might support. I think we're planning to merge in these Gateway with the Meteora routes. However, we're probably not going to add the actual like Hummingbot classes and for them until the next release. In the next release, we'll probably actually add classes in Gateway to actually interact with the COLMM endpoints in like Meteora. And then I think we should also try to incorporate Uniswap and Radium. Actually, maybe not with the new structure, but definitely Radium using the new structure. Hopefully, V3 Uniswap the V3 connector with the new structure as well. Then that'll give us a chance to standardize some of these schemas, because right now, these schemas are kind of fixed for Meteora, but ideally, there's kind of fixed schemas for adding liquidity or opening position that we're using across all the COLMM integrations, and I think we should also add integrations for adding and removing liquidity to the regular AMMs as well along the way. So in the next release, we should also be able to start doing better error handling and that kind of stuff. But yeah, at least for now, we're kind of just starting by adding these basic endpoints for Meteora that allow you to basically fetch your positions. You can do a swap directly here. And you can also open a position, add liquidity, remove liquidity, and close that position. So let's go ahead and I'll just demo these routes. One thing to note is that landing a transaction is still buggy, especially when the chain is congested like this. So one reason for that is because the Jupiter connector currently uses Jupiter to kind of basically fetch kind of assign transaction, and then you can just send that directly. Whereas Meteora, we're using a different way to create the transaction, and so there's probably some issues with how we're constructing the transaction that need to be resolved in order to have it be as reliable as Jupiter right now. So that's more of a nuance in terms of like the transaction landing aspect, which I should be able to improve next month when I'm in Utah for Mountain Dow. Okay. So let's go ahead and take a look at the Meteora routes. So just like we did for Jupiter, let's walk through each route. So now they're in each file. So the position owned route, you'll pass in the network ID, the pool address. So this is because we're going to define a certain pool, and then we'll fetch the position owned for that pool, and then also a wallet address. So I actually might remove this later on. Maybe we'll just send all the positions later on instead of, and make this an optional parameter. So let's get my wallet address. So here's a request. So the response is basically a list of basically that looks like this. So this first one, active bin, tells you the status of this pool itself. So currently there's 0.6 M3 in this pool. So actually we can probably find the pool here. Let's find the pool. I think I have it here. Yeah, but I believe it's this one here. Okay. This is the pool. Hell, so yeah, this is the pool address here. See FTF like this. So the active bin is -471. X amount, Y amounts. Depends. We probably have to look at that. This actually doesn't quite look right. I think. Is that right? Yeah, because this is the actual amount of M3 and this in the pool. So yeah, so we this stuff we probably have to make sure that this is correct. But essentially, this is the information from the pool, and now I have a list of positions in that pool. So the response format is basically the one that we have here. So essentially, you can see the logic of this route very easily. All it's doing is it's basically fetching a list of positions. Let's see, where is the list of positions here? Yes, first it's just fetching the pool from the address, and it's just now it's fetching. We have this I think this one here. Let's see. This one is a function on the SDK that fetches all the positions for a certain user and pair. So this is actually by LB pair. So LB pair is basically all the base token and quote token combinations that are available, and we also have a route to fetch all the LB pairs available in Meteora. So the format of this is basically all the list of user positions, and so we can fetch a list of positions we have here. All right. So next we have active bin. This one is also essentially just fetching the current price and the current bin for a particular pool. So this is a pool that we'll be looking at. So we just pass in the network ID and the pool address, and we can see the current price. So we need to revisit this X amount, Y amount, because I think I would actually expect these two to match what's in here, which is the amount of M3 and M3 and USDC. But this might be value or something like that, or something. We should probably just look at that again. Oh, actually, is this the? Yeah, I don't know what that is. Okay. So we've active bin, and finally we can quote a swap. So this quote swap is basically the same as the price route that was on Jupiter. I added this because it was added in the original LARP routes, but I typically would not recommend using this one because here you're only doing swap just with this pool, whereas if you do a swap in Jupiter, you're looking at kind of all the possible combinations for that route across all the DEXs and all the pools on Meteora. So here we define the network, the input token symbol, output token symbol, amount, and pool address. Again, we define the pool we want to define, and then we can also define an optional slippage if we want. if you don't define one, it'll use the default slippage that was in the Meteora config. So here we go. So now, yeah, it basically returns the here we go. It returns basically the estimated in, estimated out, and a minimum amount out, which incorporates slippage into account. So this is basically the price, and we can also then get other ones as well. So I think now that but I think the fun part is not just fetching information from Meteora. It's actually automating the opening and closing of positions on Meteora. So this is the part that I'm still working on, so I'm not sure if this will work. This actually worked last night pretty well, but before today's live stream, I was testing it, and I couldn't get anything landed. And I think it's because of, either the fees are much higher now because it's congested, or more likely there's probably a bug in the code that I need to resolve. However, let's go ahead and try to give it a shot. So let's go ahead and let's try to let's see. First, let's try to open a let's try to execute a swap first. That's probably the simplest way to do it. So let's do that, and let's see. I think I have. Let me check my balances first. Balances. Okay, SL address. I'm probably gonna add a something so you can like add your wallet address in the config file, because I'm just typing it a bit too often here. So let's get our balances for USDC. Shit. M3, M3, M3. Yes. Okay. Okay. It's pretty hard for you to see, but yeah. So it has the right balances. I have 0.6 SOL. I have 141 USDC and 212 M3, M3. So let's go ahead and sell some. So we could do it in Jupiter, which we did before in Postman, but now I want to do it in Meteora, and just to test out this execute swap endpoint. So here I'm going to sell 10 M3, M3 for USDC like this, and I'm not going to pass in. Actually, I will pass in. I'll pass in slippage of 5, so I can hopefully ensure that this lands. And so let's go ahead and give it a shot. Yes, I don't have a your wallet address.json file. Thank you very much. That is correct. All right, let's pray to the Solana swap gods. Okay, so now it's going to try with priority fee 150K micro LAN ports. Let's see, with a total fee. So this is actually the more interesting stuff here. So basically, what it's doing is going to every 5 seconds it will double the fee and try to get landed. We were having issues with this before, to be honest. So I'm actually not sure if this is correct, but this should be, hopefully, if this is correct, it should be increasing the fee every time and getting the transaction landed, hopefully. So we can also see what the gas tracker is for Sol. So this is actually already very high, and I am trying to do a swap in what is probably a fairly competitive tier. So I believe this is the issue. This is why right now it's taking us quite a long time to try to get this transaction landed. So it looks like it hit our maximum priority fee. This is about 0.3 cents. Actually, it's probably about 30 cents right now. So we could increase this fee, but also I want to make sure this is working. So this is also, I'm actually not sure this is failing because it might be failing because of some bug in the logic as well. Okay. So, I'm pretty sure this is because of the company. So in order to do a test, let me actually try to do this. I'm trying to sell some of my Sol for USDC, and let me just try to sell 0.01 Sol. Do I have that much? Yeah. Yeah. I'll just try selling 0.01 Sol and see if I can do that. So this should tell me if it's an issue with the with gas or not. Okay. Error in transaction. This feels still pretty low, but I just feel like I find it weird that it's not getting confirmed even at this fee, because this should be pretty, yeah, unless the market is just really attractive right now. Let me try this out. Let me try a much less competitive token. It is possible that yeah, because I'm still not sure whether this is an error with the way I'm sending this, or with just congestion on the chain itself. All right, let's try this again. Let's try with a different token, and let's pick one that's going to be less competitive. So let's do this one here. Where's this one? Let's actually see if we have this one saved or not. Let's see. Oh yeah, so we don't have that saved in there. Okay, let's try Popcat actually. Okay. All right. So yeah, I'm gonna try something else. I'm gonna actually try opening a range and a different token and see if I can do that. So let's try to find a Popcat USDC one. Okay. Yeah, let's do this. Actually, this is. Yeah, let's try this one. Okay. Okay. So do that. Let's go ahead and open a position here. What address is this? This is my wallet address. So hopefully this will tell us if there's an issue with Meteora or not. Add position. So yeah, let's do something like this. So say 0.3 to 0.5. That. Okay, so hopefully that works. Let's see. Make sure that works. So this is my pool address. I have an address. I have tokens. Oh yeah, this will, at least for now, all this does is open an empty position. So it doesn't actually add any tokens in there. So that's why this is actually a good test to see if we can just open a position on the chain or not. Let's see. increase my fee here. Yeah, okay. Yeah, this is not. Yeah. This is actually still pretty low, actually. So let me increase. Let me increase the increase my minimum fee here. So it's going to increase this at a higher rate. So now let's try that. Right now there's 4 million, right now use 4.6 million micro LAN ports. So that's actually the current high rate. So this is actually, I guess, in some ways, this is expected behavior. But I think that days like today is a good test because last night I was working totally fine, I swear. But I think that's why, and I'm pretty sure I didn't change anything in the code really from yesterday to today. And the only real difference is the level of congestion on the blockchain. But that's why I want to make sure that this actually works well before proceeding. But you see, this last one, I feel like this last one should have worked. So that's why I'm not confident this is actually an error in our code versus something else. But let me try this just to make sure. Let me increase the maximum just to do. I'll increase it 10,000 just to see if I can get one transaction landed, and then I'll start from a lower base as well. So hopefully, if this doesn't work, there's definitely an error in the code because I just increased my max priority fee to like $3 or something like that, or possibly even more. So I think it's 10,000 LAN ports. Where is that? Yeah, actually 0.01 sol. Yeah. Actually, I think that's actually, yeah, that's actually that's 0.1 sol. So that's $25 actually. So I'm gonna do a $25, potentially lose $25 if I, or not lose, but actually, well, let's see. But yeah, there's no way that if I'm willing to pay $25, I should definitely be able to get a transaction landed here. So if I can't, it probably means that there's a bug in the code. All right, so now it's using 500,000. Yeah, so it's 5 million. It's already attempting transaction 5 million micro LAN ports, which is not that high. So now it's using. So now this is 0.1 sol. All right, this is 0.00 sol. Okay, fair enough. Maybe I can increase the fee a bit more. Actually, this fee is still pretty low. Okay, 0.02 sol. Oh yeah. One question from the audience. Yeah, this is Mac OS. I mean, I would say, yeah, I would recommend Mac or Linux if you're, or you can use WSL as well. So still pretty low. I really feel like I should be getting confirmed here. So that's why I feel like this actually might be an error on my part. I might be sending the transaction wrong or something like that. So yeah. Anyway, so hopefully he'll be back next week while I do this, but yeah, see, this is actually pretty low. So I'll do one more 0 here. I'll try this again. This is the last test, but if this doesn't work, this is definitely a bug. I'll start this here in that lower. I'll start this at 500,000. Yeah. There's probably an error. There must be a bug in the code somewhere, because I mean, there's no way this should take me this long open position with this if I'm willing to pay this kind of fee rate. All right, I'm gonna stop it here. Yeah, but yeah, I can show you that this works if I just start again and run Jupyter. This should actually work better, because basically what's happening is that Meteora, the way it sends transactions is uses this method called send and confirm transaction, because it's using unsigned transaction, whereas Jupyter, the SDK gives you a signed one already. So I'm using this other method called send raw transaction. Anyway, the details are not that important, but basically there's some way I'm kind of constructing the transaction that's not correct right now. I probably need to fix that, hopefully the next couple of days. But I do think the Jupyter connector is ready for testing. So let's actually, we can verify that by let's pass in the let's see, mainnet beta Jupyter. This is all the stuff from Postman we didn't have to fill out, but we can fill out the base and quote here. So let's fill out base M3, and then we can say sell 10 of it. Address is this one. That. So here we're just selling 10 M3. Oh, now the swap API failed. Oh, okay. Let's see. So that one was confirmed pretty easily, and then if we pull up the transaction here, we can see. Yep. So here's the transaction. Swap 10 M3 for this much USDC, and the, let's see, we can set. Yeah, the privacy was pretty high. This is actually pretty high. This is like 18 million prior land ports. That's why it cost us $1.27 to do the swap. The reason that it did this was because we were sending it with this minimum priority fee, and then increase it. So actually priority fees are actually very high right now. So that is why it's possible that the failures on the Meteora side were actually correct. But there's something I need to look into, because I think getting transaction landed, even when fees are elevated like this, I think is important, because then it's up to the user. Like, do I want to pay $1.27 priority fee in order to trade on days like today, or do I want to take 5 minutes if possible, or to land a transaction, or not trade at all when fees are this high? So great, yeah. So not the exciting Meteora demo that I wanted to show, but I do think that this works correctly. So I encourage you to try out the endpoints yourself in Swagger or in Postman. But I think that if you actually want to run a bot, the one that does work is Jupyter. So you should be able to run like an arbitrage bot and Hummingbot between Jupyter and Binance, or let's say between Jupyter and KuCoin. Okay, so I think next week, I'm not sure if I'll be presenting. Maybe I will, or maybe Fede will. But hopefully at that point, we'll have more. We'll have more of the Solana, like in Meteora, connectors, like basically working properly so that they're more reliable, even when the chain is very congested, like today. But I think that hopefully it gives you some of the idea of like the challenges that we face when designing a system that can trade on blockchains, because we have to handle we have to standardize the inputs like this so that these connectors are doing the same thing across the board. But I think it's also identifying the right structure for how to structure the code so that in the future it's more maintainable and allows contribution by the community. I'm pretty confident that this new structure that we have for Meteora is going to be a lot better, because now we have a single like a client that handles all the heavy lifting and kind of really interacts with the SDK. This config file is the same as before, and then this routes file pulls in the route from each of these files in routes. So what this should allow us to do is ensure that the key routes, like adding liquidity, removing liquidity, are standardized across the board. But it should also allow developers to add routes that are unique for their own connectors. So in the future, I think we'll see a lot more different types of connectors in the future, because it's more flexible, and then now it doesn't have to. The connector doesn't have to fit a standard. It just needs to. Kind of like if you want to standardize endpoints of any kind, then you can do so here. So I think for external contribution, I probably want to hold off on at least 1 or 2 releases in order to make sure we have the structure correct, and to make sure we can apply it to Uniswap or to Radium, and to develop some standardized schemas. But the idea is for the community to help contribute to this, and also to help maintain it as well, by ensuring we have the right defaults, ensuring that we have the latest ways of landing transactions, and also improving the way that we're doing things like resolving symbols and those kind of things. Okay, all right. Hopefully that was a good demo. Yeah, thanks for using Hummingbot, and we'll see you on Discord.